Hello, my name's Bob Willis and welcome to Defect of the Month. Now shortly in the UK we have a thing called Red Nose Day, and Red Nose Day is part of a charity event which happens in March each year. Now if anybody would like to sponsor me during any of my presentations during the next couple of months, I'll be more than happy to use and wear a red nose during the presentations, and I'll send you obviously proof that I've done that. So if that's something that appeals to you, you'd like to sponsor me as part of Red Nose Day, this special charity in the UK, let me know. Thank you very much. So now let's continue with Defect of the Month and solderability testing. Now, over the last 3 or 4 years, I've been experimenting with low temperature materials, and the thing here is that most engineers and most research projects have concentrated on reflow technology, but I'm interested in the whole manufacturing process, as most quality and process engineers are. And the important thing is understanding what other things might change in the process. So what about solderability? Will reflowing at much lower temperatures with wave soldering, selective soldering, reflow, and of course rework and repair have an impact? Will marginal solderability have an impact on yield and quality? So I wanted to experiment with my 2 simple shop floor tests. This is the microscope slide test for testing out components during reflow soldering, which I'll illustrate to you in a moment, and alternatively using wetting indicators on PCBs. Now both these techniques I've been using for years, as of a number of other engineers of course. Now when you test surface mount components in the manufacturing process just using glass slides, this is an ideal opportunity to simulate the process and see if wetting occurs. And fundamentally what you do, you take a microscope slide, you print solder paste onto the glass slide, you place the component into the paste as you would on a PCB, and then run it through the pizza oven, or the reflow process to be more accurate. And what you should see is all the solder paste reflow and wet the termination, and really all that's left on the glass is the flux. That is perfect solderability, and you should be able to look at coverage of the material onto the termination. Now of course, as you know, with low temperature materials we're reflowing at lower temperatures. So what is the impact on components? One of the other nice things about this simple test, which is not new, you can use it for area array package, BGAs, things you can't see underneath, and really with BGAs there is no other test. There's no reason why you can't use the traditional wetting balance test with low temperature materials. You just need to define your test methodology and also get pellets which are made of the alloy you're going to be using. So this is tin bismuth silver. So that's no problem. In terms of the solderability of a PCB and wetting indicators, all you've got is parallel tracks on a PCB, and during the printing process you print spots of paste directly onto those strips at ever decreasing separation gaps. And during the reflow process what will happen, all the little spots will join together and you'll be left with some that do not coalesce. So that's a measure of your solderability. So you're using this as a comparative test to other products or other processes that you're running. But if you always get a very similar result, then nothing's changed with your PCB quality or finish. And you might like to share these results with your PCB supplier. Now each one of these techniques is available as a guide, which I can provide if you like, but I've illustrated it on this video how to do both these tests, and hopefully it should be plain sailing for you. Now in terms of solderability experience so far, I haven't really seen a lot of difference between the surface finishes rankings when you compare them with low temperature alloys or lead free. So those that rank poorly anyway are the same, and those that rank pretty high are the same. So that's good news in terms of solderability and solderability assessment. Thank you for watching Defect of the Month.